mathematics class. This class is for class 9 and chapter we are doing is circles, that is chapter 15, and we are following the textbook ML Agrawal Understanding ICSE Mathematics. Now in the previous class we have discussed up to question number 17. Now I move on to question number 18. So this is the first part. I will read out the question, though I have already made the figure from the textbook. In the figure 1 given below, OD is perpendicular to the chord AB. OD is perpendicular to chord AB. It is given that OD is perpendicular to AB. This is given. They are referring to the figure. They say figure in figure 1 given below. So I have already made the figure, and according to the figure I will mark what is given, what is to be proved, and if construction, if any, then I will be drawing it. Now they say OD is perpendicular to AB. OD is perpendicular to AB, to the chord AB of the circle whose center is O. Chord AB of the circle and the center of the circle is O. This is the center of the circle. If BC is the diameter, now BC is the diameter, it is also given that BC is diameter. Then what we have to prove? They say that prove that CA is equal to twice of OD. This CA line should be proved as 2 times of OD. Now, first point, we will start with the proof. What is the first point? They say that OD is perpendicular to AB and O is the center of the circle. It means O is a line which is perpendicular on the chord AB. If it is perpendicular on the chord AB, it means that it divides the chord AB into 2 equal parts. It implies that D is the midpoint. D is midpoint of chord AB. Why? I have already explained you. Because from O it is a line which is perpendicular to the chord AB. If it is perpendicular, we have learnt according to the theorem that a line perpendicular from the center on the chord bisects the chord. It means AD and DB are equal. If they are equal, it means D is the midpoint of AB. So I have written D is the midpoint of AB. Reason I have explained. Now next point, they say that BC is the diameter. If BC is the diameter and O is the center, it means O is the midpoint of BC also. We can say that O is midpoint of chord, even you can say chord, in bracket I am writing diameter, and then because diameter is the longest chord, of BC. Now O is the midpoint of BC. It means this OC and OB are also equal. Now we move back and we remember that we have studied in intercept theorem and midpoint theorem that if in a triangle, if a line joins midpoints, 2 midpoints of if in a triangle a line joins midpoints of 2 sides of a triangle, then it is parallel to the third side and half of the third side. So if you consider triangle BAC, what we can say? In triangle BAC, you can see a line OD joins midpoints of the sides of triangle BAC, of the sides BA and BC. So OD will be parallel to AC and OD will be half of AC. We can say OD will be parallel to AC and also OD will be half of AC by midpoint theorem. Midpoint theorem. This we have studied in the previous classes. Because it has been, we know that in a triangle, if a line joins midpoints of two sides of a triangle, then it is parallel to the third side and equal to the half of the third side. So this line OD is equal to half of the third side, that is BC. So that is your proof, hence proved. Now we move on to the second part. I hope this was very easy question. Only the thing was, if you remember the basics or the previous chapters that are being taught, then it is very easy. So if this type of question comes, we can, or the teachers may judge the knowledge of this chapter also as well as previous chapter also. So these types of questions are more probable to come in the exams. Now we move on to the second part. Now second part of question number 18 is again based on the figure. So I have drawn the figure. They say in the figure 2 given below, O is the center of the circle. So first thing, I have drawn a circle and its center has been marked as O. O is the center of the circle, number 1. Then they say AB and AC are chords of the circle such that AB is equal to AC. What is given? Chord AB is equal to AC. This AB chord and AC chords are equal in length, and we know that chords which are equal in length are equidistant from the center. This is a theorem, means I'll write the theorem. Equal chords are equidistant from center. Now this is the important theorem that will be utilized in this question. So first of all, it is given that AB is equal to AC. Then they say that OP is perpendicular to AB. OP is perpendicular to AB, so I have made a 90-degree sign so that OP is perpendicular to AB. And similarly they say OQ is perpendicular to AC. Prove that PB is equal to QC. What you have to prove? You have to prove that PB is equal to QC. Means this line and this line are equal in length. We know that AC and AB are equal. It is given. So this is given. So now I start with the proof. This is to prove. Proof. What is the proof? First of all, AB is equal to AC, that is given. It means half of AB will be equal to half of AC. And half of AB is AM as well as MB. So in place of half of AB, I will be writing MB. And in place of half of AC, I will be writing NC. These two things are equal. If n is the midpoint, because this line is perpendicular, ON is perpendicular to AC, and if ON is perpendicular to AC, it means it divides AC into two equal parts, or simply it bisects. So this part and this part are equal. AN is equal to NC because N is the midpoint of the chord AC. Why? Because ON is a perpendicular on AC. Similarly, OM is perpendicular on AB. It means AM and MB are equal, or they are that AB is bisected at point M. Now, if angle ANO is 90, similarly angle QNC is also 90 because they are vertically opposite. Or you can say this is 90, then this is 90, this is again a straight line, this is 90, so this is 90. So simply I will take these two triangles, triangle number 1 and triangle number 2, because these two sides, to prove QC and PB, in any case we have to consider these two triangles. So we will say in triangle QNC and triangle PMB. One more thing I want to explain before I start with the proof. OP and okay. OQ and OP will be equal. Why? I am writing it here. OQ is equal to OP. Why? These are the radius of the circle, because from center to the circumference is OP. It means it is the radius, and from center to the circumference Q, OQ, it is also the radius. So OQ and OP are equal since they are the circumference. Also, we have proved that ON is equal to OM. Why? ON and OM are equal. Why? Because they are the perpendicular distance from center on equal chords. This is what it is written. Equal chords are equidistant from the center. Means this chord AC and AB are equal, so their distance will also be equal. So ON is equal to OM. That is why the reason is given, perpendicular distance from center on equal chords. Now if ON and OM are equal, if I subtract this equation from this, let us say this is equation number 1 and let us say this is equation number 2. I am subtracting equation 2 by 1. So what I'll get? OQ minus ON must be equal to OP minus OM. From left hand side I am subtracting left hand side, so OQ minus ON, so that is why OQ minus ON. OP minus OM, so OP minus OM. Now look in the diagram, OQ minus ON will give you NQ. So here I can write NQ is equal to OP minus OM will give you MP, and this proof will be required in the main proof. So this is one thing that we required. That is why I have shown the explanation. Now in triangle QNC and PMB. In triangle QNC you can say angle QNC is equal to 90 is equal to angle PMB. Why? I said if this is 90 then this is 90 because they are vertically opposite. Similarly if this is 90 this also is 90, so vertically opposite. So I am saying QNC this angle and PMB this angle are equal and they are 90 degrees. So first point. Why? It is explained. Now second, we can say that NC is equal to, this NC is equal to MP. NC is equal to MB is equal to MB. Why? Because it has been proved above, where this is the proof. MB is equal to NC, so MB is equal to NC. Then third thing, we can say that NQ is equal to MP. Again proved above. Here, from here, NQ is equal to MP, NQ is equal to MP. Now this NQ and MP are equal. First point. Second, these two angles are equal. This angle and this angle is equal. Third, this MB and NC are equal. So by side angle side, we can say triangles are congruent. So we can say therefore triangle QNC is congruent to triangle PMB. So we can say therefore PB or QC is equal to PB by CPCT, and that is your proof. Hence proof. So this is in this question we are using congruency that you must have studied in the previous classes, and as well as we are using the theorems of the circle that is we are studied just now. So this is the solution of the question. Now we move on to the next. Now next question is question number 19. This is also based on the figure, so I'll just read out the question. In the figure 1 given below, a line L intersects two concentric circles at the points A, B, C, D. Prove that AB is equal to CD. Now first of all they say two concentric circles. What is the meaning of concentric circles? Two circles or more circles which have same center is known as concentric circles. Suppose I ask you to draw a circle with radius 2 centimeters, then 5 centimeters, then 7 centimeters, then 8 centimeters. So on the same center. So you will take the center and draw 2 centimeter, then 5 centimeter, then 7 centimeter, then 10 centimeter. So these circles 1, 2, 3, 4. 1, 2, 3, 4. These four circles are concentric. Concentric means circles with the same center. So they say there are two circles, two concentric circles, and a line L. This is a line L which intersects them at points A, B, C and D. So that is I have drawn. Now they say prove that AB and CD are equal. This AB and this CD you have to prove they are equal. So first of all we have a construction in this, because we know that if there is a perpendicular from the center, it bisects the chord. So I am drawing a perpendicular from center O. Let us say this is our center O and point M. So what I have done construction, I have draw perpendicular OM on AD or on line L. Let us say line L, because if you say BC then AD will be left. If you say AD then BC will be left. So make it, we have made it in a generalized form. Draw perpendicular OM on line L. So perpendicular OM on line L is this. Now when we have drawn a perpendicular, then BC acts as a chord for the inner circle. So if BC is the chord and we have drawn a perpendicular from O to M, then BM and CM will be equal. Why? Because we know that perpendicular drawn from the center on the chord bisects the chord. So in this way we can say that BM is equal to CM. Why? Because M is the midpoint of BC. Reason I have explained, because we know that from the center if a line is drawn and that is perpendicular to the chord, it bisects the chord. So M is the midpoint. Similarly, if I say that this circle is not given, if this is hidden, then AD will act as a chord to the outer circle. So when AD is the chord, at the same time M will be the midpoint of AD, because on chord AD a perpendicular is drawn. So AM is equal to DM. So second point we can say AM is equal to DM. Again the reason is same. M is the midpoint of chord AD. Let us say that this is equation number 1 and this is equation number 2. What we are going to do, we are subtracting equation number 1 from equation number 2. So subtracting equation 1 from equation number 2. When we subtract, left hand side and left hand side will be subtracted. So AM minus BM is equal to DM minus CM is equal to DM minus CM. In the diagram, AM minus BM will give you AB. So what we are left with? AB. And in the diagram, DM minus CM you will get CD. And that is what was required to prove. AD is equal to CD. So hence proved. I hope this is quite easy. totally based on the theorem that we have studied. Now we move on to the second part. Now next question is question number 19b. That is also based on the diagram. I'll read out the question. In the figure 2 given below, chords AB and CD of a circle with center O intersect at E. So AB is a chord, CD is a chord, they intersect each other at point E, and the center of the circle is O. They say OE bisects angle AED. OE bisects angle AED. It means AEO and DEO angles are equal. Implies that angle AEO is equal to angle DEO, and this is given. I am writing what is given. Then they say prove that AB is equal to CD. What we have to prove? You have to prove that AB is equal to CD. Means you have to prove that the length of these chords are equal. So how can you prove them? We know a theorem that equal chords are equidistant from the center. It means if I draw a perpendicular on this chord as well as this chord, so and if I prove that these perpendiculars are equal, it means the length of the chords will also be equal, because we know that equal chords are equidistant from the center. So if their distance from the center is equal, then the length of the chords will also be equal. So our main objective is to draw the perpendicular and prove that the length of both these perpendiculars on the chords is equal. So I am drawing a perpendicular from the center on the chord AB. Let us name it as M. And similarly I am drawing a perpendicular on CD, and let us say it is N. This is the construction that I am doing. This is the perpendicular. So I will be writing as construction, draw OM perpendicular to AB and ON perpendicular to CD. Now we will take these two triangles, triangle number 1 and triangle number 2. So now my proof starts. What is this? We will say in triangle OME and triangle ONE. First of all, we can say angle OME is equal to angle ONE is equal to 90 degree. Why? Because that is my construction. We have constructed OM and ON perpendicular, and we will be proving that OM is equal to ON. If OM and ON will be equal, it means their distance from the distance of both the chords AB, distance of the chords from the center is equal. Then obviously the chords will be equal. So OME is equal to ONE. OME is equal to ONE. This angle and this angle is 90 degree. Second thing, we can say angle MEO. Angle MEO is equal to angle NEO. This angle. Angle NEO. Why? It is given. Here only AEO. AEO means MEO only, and DEO. DEO means NEO. So these two angles are equal. Third thing, we can say that OE is equal to OE. In both the triangles, OE is common. You can see this OE belongs to this first triangle also as well as second triangle also. So you can say by angle side, these two triangles are congruent. So we can say triangle OME is congruent to triangle ONE, and reason is angle side. If the triangles are congruent, then all the 6 elements of one triangle are equal to the corresponding 6 elements of the other triangle. So we can say OM is equal to ON. Therefore OM is equal to ON by CPCT. Hence we can say, hence AB is equal to CD. That is your proof. This is the proof. So this again contains congruency as well as the theorems. Now we move on to the next. So I hope these two questions that we have done today, basically there are two parts of 4 questions that we have done today. You would have understood them. Please watch this video of this chapter again at least 2 times carefully, because all these things are there in class 10 and nobody is going to teach you all these things in the next class, and next will be your boards. So please be ready for that. Till now, stay tuned, stay blessed. Thank you. Have a nice day.